should be working now. Hey. Let's see, is everything working? Oh, it's private, isn't it? Huh. Let's see. Alright, everybody. Are you... I don't know, chat, I don't know, Bernard is king or something in the chat if you can hear me. Where do I put this? No, where's Bernard? No, that's fine. Anybody out there? This doesn't seem to be working. Oh, hey guys, what's up? Sorry, for some reason my computer's not showing the chat, but my phone is, so there you are. What's up, people? Tan 35.6, okay. I knew that. There he is. Look at the little guy. Ron Winor, you want me to make an Among Us? Really? No, I didn't forget X. Oh, you did though. Okay. Let's see. How are we gonna make an Among Us? This is funny. Alright. I don't know, man. Alright. I'm just gonna... move... Oh. You know what? We've already got golfers in the chat, huh? That's definitely an Among Us, yeah. Look at him. No, it looks like Eva from Wally. Yeah. Quit judging. Hey, I'm not good at implicit manipulation. Two free chars, eh? I'm just watching the live chat on my phone, because why not? Could you please make an Among Us? Oh, you're a random scientist. Nice to meet you. Egg Us. Perfect. Alright. Hey, I'm saving a graph. Don't get mad at me. Is my mouse loud? Wide Among Us? Dude, I don't even remember how to make a normal Among Us. Let's just do this in the most basic way possible. Actually, you know what? Let's go to geometry beta. Because why not? Alright, here goes nothing. So we're gonna have one there. I'm gonna do one here. Alright. Yeah, I know what I'm doing, don't worry about it. Okay, then we're gonna go yeah, so this guy right here, right? We're gonna do we're gonna do this in the most jank way possible, because why not? And then what, can I put this guy here? What? I can put, oh shoot, I just deleted them. Frickin' heck. I think Eggmogus did deserve a graph of his own. I mean, what's up with you guys? It does this in a weird way. If you drag these out, and then you close this out, it just deletes the whole thing, right? But for some reason it's more intuitive to me if, when you drag these out, like, they become sort of extensions of the little icon things. Oh, you can drag them back, cool. But it just makes sense if you close this out for them to just go back to being icons. Maybe that's just me though. Let's see. Oh, we could just, hang on. You guys ready for this? I'm sorry, I'm using some pretty advanced techniques here. Let me know if you can't follow along. Yeah, and then we got. All right, there we go. That's pretty pristine, huh? Yeah. Hang on, wait. So what's that function that turns a polygon into an implicit? Anybody know it off the top of their head? I don't. Oh yeah. No, geombeta is pretty cool actually. I haven't used it very much either, but I do have. Let's see. Oh yeah, there's this guy. I made the geometry beta symbol in geometry beta. This took me like an hour and a half for some reason. But I mean, it was pretty cool because you use the sliders to make the points, and you can just like click, like put a point on the thingamajiggy, right? And then when you drag this guy out, you can make him filled. Wait, how do you? Ah, shucks. I don't know. You can do something. I forget what I did. I don't know. I mean, using geometry beta to make geometry beta, it's pretty easy, relatively speaking. Let's see. What else do I have here? Oh yeah, those dumb rounded rectangles I tried making. What was I even doing? I don't know. Yeah, I don't have very many graphs. I'll just go back to normal desmos. Yeah. feel like I could make a rounded rectangle much more easily in just the normal desmos though. Like, hang on, yeah. I don't even know, man. What if we do geometry meta? Geometry meta? What is that? You know, what if we just... No, what the... I'm not gonna click on random links. Geometry vector images. What the heck is a geometry? What? No. No, I did not mean that. Why was I why was I getting results for geometry? Ah, whatever. Oh, yeah. I don't know, apparently it's a real word. Or maybe too many other people have made that typo. Okay. I mean, that's what I'm saying. I just realized the stream's delayed, so everything you're saying I'm responding to, and then, okay. Yeah. I'll just... Can I do that? It's asking me to sign into YouTube on my own stream chat. That's very funny. I'm just gonna enter my credentials right now. Oh, two-step verification? Yeah. Oh, hold on, do you know of any, what is it, encoding thingamajiggies, well, shoot, it was like, 64-bit hex code things. I did it for an April Fool's joke one time. I can't remember the name of it, though. Oh, base 64, that's right. Base 64 encoder in Desmos. Why not? Oh. Now that's bizarre. What the heck? There we go. My own stream started playing on my stream. Alright, here's my volumetric mesh renderer. It takes a very long time to load. Why is it telling me stuff about moderation? Perfect, now I can send a heart in chat. Whoa. Sweet. Okay, let's see. Can you see this fine? The lighting volumes, whatever it is. I want to figure out a way to make this graph faster. If you've got any ideas. Because it's about 120 something lines, and every single one is running this huge ray triangle intersection, like multiple times a second. Oh, maybe it's because I have all the polygons enabled as clickable. That might have something to do with it. Where did I put that? Disable click. Oh, dude, there's this super cool, super duper cool. Hang on. Yeah, there's this cool thing called Desmodder. I'm not sure if you've heard of it. Yeah, look at all these fancy things. Yeah, anyways. What if I just scroll through all my graphs and pick a random one? That could be fun. We've got reflection off of implicit. Better. When did I make this? Oh, that's neat. Hold on. Oh yeah, cheats. Man, is there a way to lower latency or something? It seems like it's like 40 seconds or something. But yeah, no, Desmoder is definitely a cheat engine. You know, they can ban you if you use Desmoder for the art contest. Yeah. Did I just show my Wakatime key? No, okay. Wait, why is Wakatime not enabled? Come on, man. Unbelievable. Custom math quill configuration? Oh, I actually haven't used any of this yet. Not gonna allow that. Whoa. More Greek letters? Hang on. Oh. Well, that's disappointing. More Greek letters, eh? Huh. Actually, hang on. Let's see. We've got all this good stuff. I've never used Wolfram to Desmos. How useful is that? Oh wait, Natron's plugin. Is that the hold on, which one was that? Sorry, I just paused for a hot minute there. Was it the Wolfram to Desmos or the what was it? The Greek letters, right? Yeah, it doesn't seem to work. Let's see, what are other Greek letters? Phi works, that's always worked. Phi theta, right? Pi, of course. I mean, what other Greek letters do people use on a daily basis? I already tried epsilon. Alright, anyways, let's just see what happens if I run this for a while. It's running pretty slow, too. Don't know why that is. Do I have like a, do I not have gravity? Yeah, gravity's enabled. Yeah, when did I do this? We've got all this good stuff. Sorry, I'm seeing your messages now. I mean, your chat things. The custom... Yeah, I didn't know Natron made this, actually. He made all of these? That's pretty dope. Pretty cool. Yeah. Oh, I wanted to try something with Glesmos, actually. Hang on, where was it? There it is. It's like the worst, most laggy graph I've ever made. Okay, it's pretty laggy, but what if where's Glesmos at? Yeah, and then, alright, is this gonna break my computer? Is it just me, or is that not any faster? Is it just all the shaders that it's making are not hang on, what's the word? Yeah, what? This is Glesmos. It's supposed to be fast, isn't it? Can't render that with Glesmos for some reason. What? Yeah, I don't know why that is. There's also something funky going on here with the pixels. Will we talk to Fireflame about that one? Or is it just because... Oh, it's probably because it didn't recompile or anything. Yeah, I don't know. Also, I totally stole this this line segment SDF from a shader toy, but but no, yeah, Glesmos is slow with lists. Pardon my lisp if I have one. See, what if I split the list up though? Is that still just as bad? I'm pretty sure it's just as bad. Like, this is the least efficient way to do it, but whatevs. Alright, let's enable Glesmos for all of these. It's already Whoa, what? I was clicking on this one. The arrow is still on the red one though. That's bizarre. Yeah, that's really weird. I don't know what's... It's probably like the UI lagging or something. Yeah, look at that. Very weird. Yeah, no, still just as laggy. Of course. I mean, it's still doing just as much. You know, I had an idea, a pretty cool idea, if I do say so myself. You could have like a bunch of points, right? And for like an n-body simulation, actually, let me just go to one of my n-body simulations right now, and let's see, where's the simplest one? I think it's like this one. Big epic, don't touch. Why did I write that? Let's do collisions. I never implemented collisions. Let's just do this one. And then, wow, was I planning to make this for the Desmos art contest? Maybe. I don't see why this took 89 lines. It shouldn't have taken that much. What can I do? Yeah, okay, so my idea was to like have a decorator for each... Shoot, what did I just do? That's fine. Have a decorator for expressions that, like, of lists that take a ton of computation, whatever, power stuff. Man, I'm not explaining this very well, am I? But my idea was that you have something like at GPU or whatever at the beginning, right? And since Glesmos already has a way to compile Desmos expressions to like a WebGL shader, I don't see why we can't just do the same thing, but instead of outputting as a render texture or instead of outputting to like a canvas, why don't we just output to a list that we specify ourselves? So like maybe even, oh shoot, scroll wheel loose. Maybe instead of like this, we could have like a function like predefined or something called @GPU, right? And like, I know it's not totally compatible with vanilla Desmos, but what if we just had like the output would be a list called like points or something like that, right? And then the input is just wait. Oh yeah, and then the input would just be like another list that was already calculated with what's it called? With like the entire graph, you know what I'm saying? Like, so instead of like compiling the expression that takes a ton of like CPU to calculate, it like stops it from doing that, and then it just sends it to the GPU instead, or like a buffer. Am I making any sense right now? I'm starting to think I'm probably not. No, but like, my point is that we already have the ability to turn Desmos graphs into like GPU powered beasts, you know? I mean, minus the list thing, but we can do it with one. Wait, no, actually, no, that's a great idea. Hang on. Okay, so there was this one, hold on. Pixel Pusher sent something pretty sick as in Open Graph Ideas. I think it got like 5 stars or something. Yeah, line stippling. Yeah, hang on, let's look that up. I'm just gonna go into Open Graph Ideas now. Anytime I do this. But like, what if we did this, right? And we could make a black and white image using only one implicit equation, right? So instead of doing what people normally do and having like multiple layers for different brightnesses, right? We could have all the different brightnesses as one optical illusion, and maybe run that through Glesmos. That would be pretty cool. Oh, you pronounce Glesmos as G-Lesmos? That's pretty radical, man. I don't even know. G-Lesmos. Pretty weird. Oh, let's see. What did you write? You could probably do it with web GPU compute shaders. Yeah. It'll still be slow, definitely. Yeah, no, sending stuff between the CPU and the GPU is definitely the slowest part. But, I mean, I honestly don't see why you can't, shoot, that's a pretty loud car in the background. Let me just, yeah, okay, I mean, we've got, like, something like this, right? It would be super fast if you could just, like, have a grid of points in Desmos, right? And just send it straight to the web GPU compute shaders, like you were saying, right? I mean, it wouldn't be as fast as like doing it on a website like this, but it would. It's just adding one more step, right? I mean, it's only one step. Like how much impact can it make, really? I don't. I mean, it can probably have a pretty big impact. But no, yeah, line stippling I think is probably like the best idea. Yeah. I don't know, it's a pretty cool idea too. I have no idea how I would do it here in Desmos though. Like you could have a bunch of lines, like I guess horizontal lines, so just oh, hang on. And, or that's vertical lines, but whatever. And it still takes quite a bit to render, but if you have just one equation like this, like it renders with Glesmos super duper fast, right? And you can only have so much detail before it, like, you see the pixels start overlapping and all that. But if you have like a high resolution image like this, right? And then you just dictate the width, like the width of these lines, by plugging in some sort of like some sort of distance function, or I don't even know. Oh wait, hang on. What if I just do that right now? It's not gonna look pretty. It's not gonna look very pretty, but actually, I could take my ray tracing graph. Yeah, let's do this one. It's like the fastest one I have. And instead of making pixels, we just do that line stippling thing. And the thing is, it's all discretized. Yeah, whatever. So if I have all these pixel coordinates, I'm storing everything in lists, right? So I can't really convert that to something implicitly rendered very easily. Like, you see there's like a storage function. It's 10 lines of just pure lists max length. Man, this is a tough idea. I'm just trying to figure out how I would do it. I really like that idea though. I don't know. Geez, no one else has joined chat. I want other people to contribute. Maybe. I don't know. If they want. OpenGL. GLesmos. Yeah, I'm still thinking about that. GLesmos? GLesmos? It's just Glesmos. I mean, it's easier to say, right? Nobody joined. Among Us stream. Okay, yeah. Sorry, I'm just checking the Discord chat. Let's see. I really want to do this line stippling thing now. It's just stippling is such a disturbing word, but Glesmos bad, you say? Glesmos better? No, I'm gonna say Glesmos gang. I disagree with Glesmos. It's just too many syllables, and it's unnecessary. I see someone else just joined. I don't know who that is, but whoever it is it Glesmos or Glesmos? I don't even know if the person who just joined uses Glesmos, but is it Glesmos or Glesmos? Okay, yeah, no, they left. Whatever, it's fine. Line stippling. How? Alright, I'm gonna go back to... Alright, so we got diagonal lines. I think that's pretty cool. You could also do like curved lines. I don't know why I put that in parentheses. Oh, that gets us a Bernard pretty quickly, huh? Oh, that's so weird. Okay, that's fine. Yeah, okay, so we've got thickness here. And we could like have a thickness function, I'm thinking, right? And if we define the thickness function, t-thickness, that's kind of weird. Like the thickness of any point at x, y would be, I mean, we have to cast array out of the camera, and we'll just treat those as screen coordinates, right? So we've got, it's the easiest way to do this. I just want to have like a little demo, so I'm gonna just copy and paste a, whatever. I'm gonna copy and paste the ray triangle intersection. Oh shoot, I just totally deleted that graph by accident. Ah, that's fine. Okay, so it's a pretty big function, it's fine. Yeah. Let's go remake that graph. You'll probably be proud of me for not spending an extra graph hash on that. But yeah, so our idea was we've got x minus y, right? So we've got these lines, and then we're going to try varying their thickness based on an array that we're just going to project out of the screen. Or out of the... Shoot, it didn't even copy. That's a scam right there. I'm totally just going to steal stuff from my other graphs because I really don't want to type out that whole thing again. Alright, Control C. There we go. We're going to put that in a folder because it's probably the biggest expression in this graph. Right, okay, so then how did I do this? Shoot, this is getting laggy. Okay. Just take off a digit. Should be fine. Alright, the stream's going to be ending in about 5 minutes. But, well, we're still going to try this, because why not? So I've got these intersection and integration functions. This is for light passing through the volume. That's just for this graph. But I'm not going to do volumetric rendering plus line stippling. That would not look good, in my opinion. It would just be too much going on, honestly. But, okay, so, geez, it's still rendering? Yeah, you can tell, because everything's blank. But, look at that. Doesn't that look beautiful? It's ray tracing, everybody. Okay, that's not the focus, though. So, we're going to take, where was our, yeah, here it is. So we've got our ray triangle intersection function is going to be running multiple times. This is for each triangle. And then we're just taking the max distance of each intersection, just like the most inefficient way to do it. But actually, no, that's not what this expression is doing. This expression is figuring out the density of the volume between the two triangles that a ray intersects. And it only intersects two triangles. After that, there's like a second cycle it goes through, and that is the non-volumetric triangles. So I actually didn't finish this part, but if you look at the thumbnail, it looks pretty, oh shoot, yeah, right there, it looks pretty cool. The volumes don't cast shadows at the moment though. But yeah, okay, intersection and, yeah, here it is, entrance and exit points. So this takes, I believe int1, or just int, short for intersection, is the first intersection, because it has minimum, yeah, and then this is the second intersection. So actually you can tell because of the order of the vertices. It's kind of hard to decipher, I guess, but you can see this is T1, T2, and T3 as the parameters of the ray triangle intersection function. And down here it goes 2, 1, 3. And what that does is it reverses the order of the vertices. So it kind of, like, it takes backface culling into account. So the ray triangle intersection function, it only intersects with triangles that are facing a certain way. So if I flip the vertices, or flip two of the vertices around, then I can intersect both the backside and the front side of an object. And that really only works for cubes and things that are convex, but it worked for this demo. Actually, I haven't posted that on YouTube yet. I should probably do that. It's pretty cool. But yeah, no, we've got, I'm pretty sure I can use this function right here. Or not function, this expression. And I actually heavily modified the ray triangle intersection function to make it work with my intentions or whatnot. And of course I have a ton of undefined stuff because I just copied it from a graph that I just, hold on, that I don't have the namespace for. So we're going to put this as a variable, right? And these, alright, so these parameters, those are all just vertices for triangles, so we're going to ignore those for now. We can always plug those in later. But these are the juicy parts, right? So this is the direction of any specific ray, and then this is the position. And also, I just realized I'm running this through mint, the mint function, which is, yeah, it's that one. Okay, so we're good. So all I need to do is define those. Yeah, these 6 for now, and then I don't need this because I'm not running a list of rays through this function, right? I'm doing an implicit equation, so it's just going to be x and y as the parameters. So everything in here is actually going to depend on x and y, so it's going to be a huge stack of functions in the end, probably. But okay, so we're just going to get rid of that. That's good. And yeah, okay. So I'm going to get rid of all these indices because again, I'm not indexing any lists. And what I'll do is I'll make these variables all depend on x and y. So like u dear z, or UDIRZ, however you want to pronounce it. I have weird ways of pronouncing variables in my head, but each one is going to depend on x and y. So this one right here, I'm going to have an imaginary screen in world space, and the x and y coordinates are going to directly correspond to the x and y pixels, sort of, on that screen. And then what I'll do is I'll have a set z position, so I'll just do like something like that, or screen distance, I guess would be the appropriate name for it. And that'll be just the distance of the screen from the camera itself. And then what I'll do is I'll normalize all those vectors, just so they all run through the functions just fine. And when I do that, I'll have the u dir z, because that's just the direction of the ray, and then u pos z, or u position, will just be the camera position. So actually, I only need to define like a camera position. I'll just put it at the origin for now, right? And then what I can do is I can replace these three. Yeah, that should work. Yeah, they should all be starting at the origin with their direction facing outwards. And this is the only thing that should vary between each ray. I don't know why I had it differently before. I think it's because I was dealing with list, and when you have a list of arrays and you're also doing like an incremental process, like using a ticker, or I wasn't using a ticker, so I don't know why I was doing that. But yeah, okay. Yeah, okay, so the plan right now for next time is to do a line stippling style graph, where the line thickness sort of creates an illusion of brightness, right? And the reason we want to do this is because with Glesmos, we've got, oh geez, it's laggy, is because with Glesmos, this type of thing renders super duper fast, right? Only one implicit equation. So let me just look up an example. Yeah, so something like this. Except instead of having more frequent lines, we'll just have thicker lines. So that should, in theory, be a lot more efficient than doing layered implicits with different brightnesses, which would result in something that looks like, hang on, let me just Control S this guy right here. Yeah, which would look something like this. Yeah, don't worry about the name of that graph. I don't even know who's in chat right now, but yeah, so it would look something like this, but it's really laggy. So if I rotate this, you see it takes like a solid second or two between frames. And if I tried enabling Glesmos with this graph, I would crash my computer because I'm on my laptop right now. So yeah, okay, so that's the plan, is to use this to make a pretty rudimentary ray tracer just as a proof of concept. So I hope you guys enjoyed the stream, but I'm going to be ending it now. It's a relatively short stream, I suppose, but happy birthday, Ron Winor. If you don't get that joke, that's totally fine. But yeah, alright. See you guys later. If you have any more suggestions, just comment, I guess, and like and subscribe. But, Spud Guy out.